Welcome to my channel. Please don't forget to subscribe, like, share and comment. In this math tutorial, we are talking about geometric sequences. Now the question for today reads, the first three terms of a geometric sequence are 10 plus 3k, 2 plus 3k and 2k. Now the first part of this question, that is A, we are required to show that 3k squared minus 8k plus 4 is equal to 0. Now for us to show that, we need to consider the common ratio R. Now you remember we say R is equal to T3 divided by T2. It is the same thing as saying T2 divided by T1. Now we're going to apply that on that sequence that we have. So we're going to say now T3 is 2k divided by T2, that's 2 plus 3k, is equal to T2, which is that one, 2 plus 3k divided by T1, which is 10 plus 3k. You remember the method of solving equations, linear equations. You can just cross multiply this and cross multiply that. So I'm going to multiply this and that. We're going to have 2 plus 3k multiplying 2 plus 3k is equal to 2k multiplied by 10 plus 3k. Now let's simplify what we have. If I multiply this, I'm going to have 4 plus 12k plus 9k squared. And that is equal to, I'll multiply this, I'll have 20k plus 6k squared. Now I need to take everything from the right hand side and take it to the left hand side. We have 9k squared, and I'm grouping the like terms at the same time, minus 6k squared plus 12k minus 20k. You remember, if I take anything to the other side, it changes the sign. Plus 4 is equal to 0. Now simplify what is in that equation. We're going to have 3k squared minus 8k plus 4 is equal to 0. Then we've managed to show that 3k squared minus 8k plus 4 is equal to 0. Now the second part of this question, we are required to find the value of k given that the sequence converges. Now when the sequence converges, one condition must be satisfied. Now we are looking at B. The common ratio, the absolute value of the common ratio is supposed to be less than 1. And in other ways, you can say minus 1 and R less than 1. So R lies in the middle between minus 1 and 1. All right. And then we need to find the value of k. So to find the value of k, we just need to factorize this quadratic equation. Now to factorize that, we can use the method of inspection to do that. Now we can say 3k minus 2 and k minus 2 is equal to 0. Now that means k is equal to 2 over 3, or k is equal to 2. But you remember the condition says given that the sequence converges. So this value is out. It's not applicable because it's not in this range. All right. So we say, therefore, k is equal to 2 over 3. So that is the value of k. Right now, Part C of the question requires us to find the sum to infinity of the sequence. Now you remember the formula for the sum to infinity is given by the sum to infinity is equal to the first term divided by 1 minus r, the common ratio. But we need to find the common ratio. Remember, we haven't found it yet. We only have the value of k. But for us to find the common ratio, we can just check this term. It will be very simple for us to do that because we know the value of k. And the sum to infinity exists when the value of r is between 1 and minus 1. So we are checking this value of k. So we're looking for r now. We say now r is equal to, we put k into that. We are going to have 2 multiplied by 2 divided by 3. Remember we said T3 divided by T2. So we can take this. So we're going to have 2 in the denominator plus 3k. 3 multiplied by 2 divided by 3. And that is going to give us, you see, this is going to cancel with that. So we're going to have r is equal to 4 divided by 3 divided by 2 plus 2 by 4. And we are going to say now r is equal to 1 over 3. Now that will be very easy for us to find the sum to infinity because we now have the value of r. But we can look for the value of the first term, which is a. And we are saying from above, a is equal to 10 plus 3k, the first term, right here. So we're going to say a, we now have the value of k. So we say a is equal to 10 plus 3k. And we know that k is equal to 2 over 3. From above, we're going to have 10 plus 3 times 2 over 3. And that will give us a is equal to 12. Okay, so now we have the value of a and we have the value of r. We just need to put them into that equation for the sum to infinity. So we're going to have the sum to infinity. Sum to infinity is equal to a, that's 12. And we have 1 minus r is 1 over 3. So 1 minus 1 over 3. And that is surely going to give us sum to infinity is equal to 12 divided by 1 minus 1 over 3 gives us 2 over 3. And if you simplify that, we have the sum to infinity is equal to 12 divided by 2 times 3. That's going to give us 6 times 3. Sum to infinity is equal to 18. And we have come to the end of this session. Thanks for watching. Please don't forget to subscribe, like, share, and comment. Enjoy your day.